Hello, Calculus. You will be viewing this on Friday or after class on Friday, which might be Saturday or Sunday. So let's see if I can straighten it up and fly right. It's called the intermediate value theorem, which is a theorem which we call an existence theorem. So an existence theorem tells me that under certain conditions something else exists, and it must exist. So when we have we have an existence theorem, usually you'll find that they become parts of proving other theorems. So they might not have a whole lot of utility standing alone, but I will show you some ways that this one can be helpful. Intermediate value theorem. If you would write it down, if f is continuous on the closed interval a, b, notice that the brackets mean that the endpoints are included. F of a equals f of b, and k is in between f of a and f of b. Then there exists at least one number c in the closed interval ab. So this f of a and f of b were on the y-axis. Now we're over on the x-axis, and we're saying that there must be a number c in this closed interval such that, what do you think is coming? What is the point of this, do you think? Such that, can you see anyway what I'm going to do with that? That c? I'm going to throw the c into the function in such a way there is a c that will get us to that k. Alright, let me draw a picture of it and it'll make sense. I'll give it that. This is a very understandable theorem. So here we are looking at a graph, and see if I can pull back and get the theorem in. Nope, that's not pulling back. And now my tripod's falling over. Technical difficulties. Sorry to spin you around like that. Alright, see if that shows up. Alright, so some of the theorem is there. There we go. So if we have this theorem, and it says that we are continuous, this is a big deal. Continuity, and you'll see why. If f is a function, so I've drawn a function, f, and it's continuous on the interval a, b. So I'll say this is a, and say this is b. So I pick that as my interval. And f of a, so I go up from a, I hit the function, and I find f of a over here, and f of b. F of b is over here. Then there is at least one number c in this interval between a and b inclusive. So somewhere there's a c. I'll identify it in a moment, such that the function at c equals k. I forgot, there's a k somewhere in between. I'll pick it right there. And if this is continuous, it has no hops, skips, or jumps, then there must be a number, or it must be a number c down here, so that when I hit the function, it goes to k. Might there be another place c? I think I find another one right here. This also will go up and hit the function and go to k. But notice my existence theorem says there's at least ones, indicating that we may expect more than one. Alright, so graphically, and here's the wording for the intermediate value theorem, and let's see if that makes sense when we think of things in real life. Suppose we have someone who at this time is, or we'll say 3 years ago, this person was 5'4", and now today they are 5'7". So in 3 years, the transformation 5'4" to 5'7". And if that were true, and I'm assuming that time is continuous. There's no stops in time, no jumps, no backwards motion in time. So if it's continuous, a continuous function of time, if I take any number between here and here, between 5'4" and 5'7", well, I'm thinking of 5'6". Doesn't it make sense that there is someday in one of those 3 years where the person met 5'6"? There's no way being continuous from 5'4" to 5'7" that they could skip 5'6" and the value that got you to 5'6". So there has to be a day somewhere in these 3 years where this height was met. So that should make sense. And if we look at a non-continuous function and see if this works, we'll emphasize the need for it to be continuous. So suppose we have the situation where a function comes down and it has a hole, and then there's a solid dot underneath of this. Obviously, this is not a continuous function. So I'm going to try to do the intermediate value theorem, and this time I'm going to put my f of a up here, my f of b, I'll put my a right here, and that is my f of a, and I'm going to put my b down here. So this is my f of b. So this theorem says there's a k somewhere between a and b, and the theorem guarantees there's one number c in between here that will connect to k. But anywhere I put it, if I try c here, it goes up here. If I try c here, it goes down here. If I try c here, it goes down here. I can't seem to find any part of a function that will connect to k because it is discontinuous. So notice the big deal here is I have to define the function as continuous for this intermediate value relationship to apply. It is very helpful to use when you're looking for zeros for one thing, and think about that. Suppose that you have a function and you know for a fact that it has 3 zeros, say. So you know it's cubic, and it goes like that. And you found that 0 and that 0, maybe you used the packet and you found the zeros. But this 0 is eluding you. So it's not in any of the possible rational roots that we found, the possibility of rational roots from the rational root theorem. It can't be imaginary because they come in pairs. So I always calculated that one and that one. So what's left, it must be irrational. But if you can use the intermediate value theorem and you can get a value for a that gives you here's the axis, a positive f of a, and you can find a value on this side of the 0 that gives you a negative f of b, then you know by the intermediate value theorem that 0 is between this, because this is positive and this is negative. You know there must be some c in between a and b where the value zeroes out. And so then you can continue. You can pick a value that is smaller. And if you're still getting a positive and negative, then you know that you are zeroing in closer and closer. Now your a and b have squeezed in. And then if you go smaller and smaller, you can get in as close or as accurate as you want to that irrational root. Alright, so I'll let you think on that, and we will find questions more to be of the theoretical nature for this theorem. So you'll see how that comes along on Monday. So you'll be watching this after class Friday. So enjoy the rest of your weekend if there's much left, and I will see you Monday. Bye.